Well, hello guys, welcome back to Mr. G Physics, the channel that can help you to improve your physical science mark. I'm Mr. G, and if you didn't subscribe yet, subscribe for the channel so you can get all the notifications and videos I post on regular basis. This is a question related to projectile and is basically for the grade 12. The question says a man throws a stone vertically upward with an initial speed of 10 meters per second and return to the starting point. Ignore the effect of a resistance. Explain what it meant by projectile. So then we can say that the projectile is an object that moves under the influence of gravitational force only. Remember that in this topic there are two definitions only, one for projectile and one for free fall, and those two definitions are going to be asked in the exam for sure. Now, question 1.2, what is the magnitude and direction of the stone's acceleration? And then for that one we can answer here. Remember, it is going to be g, which is approximately 9.8 meters per second square downward. And that is the answer for the acceleration of the object. All the time is going to be 9.8 downward. Question 1.3, calculate the maximum height that the stone reaches. So for this question, let's write the data here. And what we know that the initial velocity of the object is equal to 10 meters per second. It is going to be upward. So we have to select direction, in which direction you want to be, positive or negative. In this case, let's take up as positive. And this is very, very important to do, guys. So you must try always to do this one when you start in the question, the calculation question. It means that if the up is positive, the initial velocity is positive because the object was thrown upward, is moving upward. What else we know here in this question for data? We know that the final velocity, which is in this case at maximum height, is equal to 0. Remember that the velocity of the object when it's at the maximum height is equal to 0. What else we have? We have that acceleration due to gravity is equal to 9.8 meters per second square. But because we say that up is positive and acceleration due to gravity is always down, you did write it there, then in this case it's going to be negative. This case is negative. And then finally, we are looking for maximum height. The ball in this case could be the displacement of the object. In this case is maximum height. Let's write it like this. Remember, this is just for you to know what we have. Now, why is the data important? Guys, the data will help you to identify the formula that best suits you according to what you have and what is being asked. Now, in this case, the best formula is, or the easiest way to do it is final velocity square equal to initial velocity square plus 2 multiplied by the acceleration multiplied by the displacement. There is everything we have, and then all we have to do is to substitute real fast. So the final answer here is equal to 5.10 meters. That is the maximum height. If you want, you can leave it there. You can write h maximum is equal to 5.10 meters. Guys, maximal height do not have directions and scalar quantity. That is the end of this question. Quite simple. And then to end the question, say calculate the time takes for the entire motion of the stone. Now, remember, the stone will go all the way up to the maximum height and then it will return down. And you need to know in this question that the time to go up is equal to the time to come down. So for this question, let's write data once more. We have the data already. We don't have to add anything. The only thing is that the maximum height is equal to 5.10 meters. Now I want to point out here that the time to go up is equal to the time to come down, right? That is important. And I'm going to show you something. The object was thrown, let's say, from this specific height with the initial velocity of 10 meters per second. So this one is quite important. The initial velocity of the object was thrown up here with the initial velocity of 10 meters per second. Okay, this object is going to go up all the way to the maximum height. This one is h maximum and is equal to 5,10, and then the object is going to return to the ground. Okay, return to the ground and reach the ground. Now, important because of velocity, symmetry of the velocity of the object, the magnitude of this velocity here is also going to be 10 meters per second. The only difference is that one is upward and the other one is downward. That is the velocity symmetry here. Magnitude of the velocity is important for you to know because we're going to use this approach to calculate. There's other ways to do it, but to me this one is the easiest one. So if we use this approach, we have here at this point, we have that the initial velocity is equal to positive 10 meters per second, taken up as positive. We did already write that one. Let's perhaps rewrite it, but we're going to select the same direction. We have that the final velocity of the entire motion is negative 10 meters per second because it is downward. That is when it reaches the ground or the hands of the thrower again. We have the acceleration is equal to minus 9,8 meters per second square, and then the displacement is going to be equal to 0 meters because the object went up starting from the initial position. Let me show you where is this one coming from. And this one is quite simple. Displacement is equal to final position minus initial position. Okay, so if the final position and initial position is the same, then the displacement is 0. Same, therefore the displacement is 0. Okay, so that is just showing. You don't have to do any of this. This one is really simple. You don't have, this is for you to understand what am I doing. Why am I going to do this one extremely simple? Well, saying that, you go to take the formula that best suits you. Very easy. Final velocity is equal to initial velocity plus acceleration multiplied by the time. Quite simple, that is what I'm saying. So now it is going to be minus 10 is equal to 10, and be careful with the direction, plus minus 9,8 multiplied by the time. Perhaps I have to move everything more to the left. There we go. I think will be enough time here, enough space. So 9,8 and then multiplied by time. And when you rearrange this one, you will get that this minus 10 divided minus 9,8. This is simple math. And then you will get that the time is equal to 2,04 seconds. Guys, this is the answer. Quite simple. Now, all this I wrote here about the displacement, you don't have to write it. You need to remember that if the starting point and the end point are in the same place, the displacement is 0. That is a note I would take. Don't forget it, okay? And this is all quite simple. Now, alternatively, you can use this one I wrote here. You can calculate the time to go up, and then you have to double it. So it's not difficult. You can try it and compare the answer. But this is all for now. Subscribe for the channel if you didn't yet. I hope it helped. Thank you for watching. I'll see you next time. Mr. G here.